plots and lines of fit. So we've been talking about situations where we have a line through our functions. So we've talked about equations and linear equations that kind of demonstrate the pattern of those points, but the function itself has always been very linear. So now we're going to look at data that's not so perfectly linear. So data with two variables are called bivariate, bi for two, variate, it varies as your variables, called bivariate data. A scatter plot shows the relationship between a set of data with two variables graphed as ordered pairs on a coordinate plane. So it really is exactly what it sounds like. It's a plot where we have kind of a scatter of points on there. So we don't necessarily have a nice straight line through them. There's not necessarily any specific pattern that we can see, but we can look for general trends. So for instance, if I look at this first scatter plot, I notice that these points, if I think about slope, they tend to kind of go in the pattern of a positive slope. It's not exactly a nice straight line, but there tends to be a trend as in the positive direction. So we would say there's a positive correlation, meaning as my x value is going up, my y value is also going up. It tends to be a positive trend there. So we say a positive correlation. We could also look at some data and see, yeah, you know what, if I was forced to really think about this, I would say that there's a negative correlation. It seems to be going down. As my x value increases, my y value is decreasing. So we call that a negative correlation. And sometimes you'll look at data and you'll just be like, if you force me to predict what was going to happen next, I have no idea. We're just going to say there's no correlation there. So for instance, if I asked you to graph your shoe size compared to how many pets there are on your house, those two things have nothing to do with each other. So we probably see this scatter plot of points that don't really relate to each other. All right, how are we going to use that? So let's take a look at how we can think about our linear equations on a scatter plot. So a line of fit can model the trend of data. So we talked about a positive trend, a negative trend, or no trend at all. Linear interpolation, we've talked about extrapolation. Linear interpolation uses a linear equation to predict about values inside the range of data. So we talked about extrapolation, meaning I'm trying to predict what might happen outside of the set of data that I have. Interpolation uses our linear equation to predict what might happen inside our range of data, and we'll see what that looks like in a second. So the table shows the growth of the world population. So here's my growth of the world population over here, year, and the population in millions. First thing we're going to do, we're going to make a scatter plot and determine if there is a positive, a negative, or no correlation. Second thing we're going to do, if there is a correlation, we're going to draw a line of fit and write an equation in slope-intercept form for the line. So we're going to force a line to fit this data. It's not going to be perfect, but we're going to force a line onto it and then write an equation for it. And we're going to use the equation to predict the world's population in 1900. So we don't have a number here for 1900, but we can probably predict what it might be. So I'm going to go to another graph here because I couldn't quite fit it on this board. So if I take my coordinate plane and I make a graph of that data, this is what this looks like. So here's my coordinate plane based on the data in this particular table. And if I look for a correlation, I would see that this definitely has a positive correlation to it. It seems like as the years are going up, and I didn't write my years on here, if my year is going up as it's increasing, that my population is increasing. So I would say this has a positive correlation. Since it does have a correlation, we're going to make a line of fit. So how I'm going to do that, I am going to look for 2 points, and I really want to make sure I draw a line that goes through 2 of these points. The reason being, I'm going to try to create an equation for this, and it's going to be helpful to use the data from 2 of these points. Can you hear my dog barking downstairs? Sorry about that. We're going to use the data from 2 of these points. So I'm going to kind of imagine what a line going through 2 of these points would look like. And what I generally look for is I look for a line to go through 2 points. I want to have it be a positive correlation line. I generally like to have any of the points that are not on my line be split up as evenly as I can on either side of that line. So if I draw a line to 2 points, I'm going to have 3 extra points floating around. I'd like it if I could have 2 of those points on one side of the line and 1 of those points on the other. Some of these points are going to make more sense to use than others. So for instance, let's kind of work through some pairs here. I could put a line through those 2 points, but that doesn't really kind of predict what's going on here. So those really aren't the best points to choose. I could do these 2 points here. However, you notice it's kind of really to the right-hand side of all the rest of the data. It's not really in the middle. It's not really reflecting what's happening with those 2 points. I could do with these 2 points here, but again, it's kind of all on one side. How about these 2 points? All right, this is not so bad. This one actually almost goes kind of through 3 points almost, and it puts those extra points on each side. I could do these 2 points too. However, this kind of looks, what am I using 4,000 to the this one kind of looks very steep. This looks really steep here. I could try these two. These two kind of really go through the middle of this and kind of mimic these ones and this one. This one kind of is off here on the edge there. So I'm going to use these 2 points. I'm going to use my, let's see, what is this, 1850, and my 1975. So I'm going to use my 1850 and my 1975 data to create a line. So that line's going to go through here. And the way my graph is done, it almost goes through that one. That one's a little bit off. I've got 2 points on one side and 1 on the other. This one's almost kind of like an outlier for this data, really. Are those the only 2 points that you could have used? No, those are not the other points. There are other points that would have made sense, but you do want to make sure that the line that you draw really looks at a pattern here. Like I wouldn't expect the next point to be way over here. That wouldn't really make a lot of sense. I'm expecting it to come up this way. Again, your lines may not necessarily be perfect. So for instance, this guy kind of looks, he's off, but that's okay. I want it to really be inside the data and have some ability to kind of predict what will happen next. So I'm going to do an equation from these 2 points here. What did I say, my 1850 and my 1975? So I'm going to lose this graph. This should still be on your paper though. And I'm going to work from those 2 points. So positive correlation was my first point. I'm going to work from the 1850 and the 1975 data, and I'm going to create a line. And we can know how to write an equation from a line when I have 2 points. So first I come up with my slope, and I end up with a slope of 24. Next I'm going to write my equation in slope-intercept form. That's what they asked me for. Slope-intercept form, I'm going to plug in one of these points. Again, we can use either one, totally up to you. I just use the first one. I'm going to plug in the y value, my slope, and my x value to try to find my y-intercept. So I do the math. I come up with y equals 24x minus 43,400. All right, so there's my equation for this particular line. And last they wanted us to predict the world's population in 1900, which is kind of in the middle of here, which is our interpolation. So I plug in my 1900, and I come up with 2,200. Again, remember that this is in millions. So 2,200 million people in 1900, which, it's kind of about, it looks like it should be a little bit more than that, but it's in that range there. It's in that range of our data. So 2,200 million people is our estimate from our line that we drew. When you make these on your own, don't worry about whether it's perfect or not. It should kind of work with what your graph is showing you. It should give you an estimate that seems to make sense, even if your equation is different from someone else's. Okay, so you should be able to look at your estimate and go, yeah, that makes sense, even if your equation itself doesn't necessarily look the same as someone else's. All right, lines of best fit and using linear interpolation.